So hello friends, welcome again to my YouTube channel, and today we are going to start a new question, and this question is reverse linked list 2. So now let's understand this question first. So we have been given a head of a linked list which is a single linked list, and we have been given two integers. First is left and second is right. It is given that left is like going to be less than right, and what we have to do is that we have to reverse the nodes in the given linked list from this position which is left to the position right, and we have to return the head of that reversed linked list. So this is our task. In this first example, you can see that this is our given linked list, and we have been given head left is equal to 2 and right equals to 4. That means we have to reverse this linked list from position 2 to position 4. Here you can see that this linked list has been reversed from which position? From second position to fourth position. And this is our final linked list. So let's understand this question and let's go through the algorithm which we are going to solve. So let's start. So what we have been given? So we have been given a linked list which is 1, 2, 3, 4, 5. So this is our linked list which we have been given to us. And the question is trying to say that you have to reverse this linked list from position this to this. This position is termed as 2 and this position is termed at 4. Now, how you can do this? So you can see that earlierly you have done the question which is going to be of reverse the linked list, which is simple question. And in that question, what you have to do is that you have to reverse this linked list from head to tail. That means you do not need to reverse in between. You can start from the head pointer and you can end it at a tail pointer. So that in that approach, concept which we are using is that we are using three pointer approach. First is going to be a previous pointer, then second is current pointer, and the next is next pointer. And using that, what you are doing is that you are every time when you come across two nodes, you are always trying to reverse this link. Again, try to reverse this link, then again try to reverse this link, again try to reverse this link. And finally, what you are doing is that you are simply returning this tail as a head. So what happened is that you have just reversed these all links and you have simply returned the tail as a head. So this has given us the result. But in this case, the head is not going to change, the tail is not going to change. Maybe it changes depending on the which pointer which we have been given. But in the normal condition or in favorable condition, it is not going to change. So we have to reverse in between. So you are not going to use that approach. So we are going to modify that approach. And in this approach, what we are going to do, we are again going to use pointers, and but in this case we are going to use four pointers. And how you are going to use this four pointer, let's see. So every time what we are seeing in this question and what is the concept by which we can decide the algorithm is, then you can see that after this reversal what you will get 1, then you will get 4, then you will get 3, then you will get 2, then you will get 5. So this is the outcome which we need. Now here you can see that in the initial stage what we have 2 then 3. That means 2 is coming previous to 3. Here you can see that 3 is previous and 2 is next one. So this is the anomaly, or this is the change which we are going to retrieve, or you can say we are going to switch. So every time we are going to see this pattern and we are going to shift, you can say we are going to interchange that positions. So you can take this pointer, you can take this pointer, you can simply move this 3 to this 2 and this 2 to this 3. So we are going to interconnect this 1 to 3, then you can connect 3 to 2, then 3 to 5, 3 to 4. Then what will happen after this? Then after you do this, you will simply get 3, 2, 4. So this is the pattern you will get after the first traversal. That means when you reverse this 2 and 3 to get this pattern 2 and 3, because this is the only thing which we need. That means 3 must come previous and 2 must come next. Now when you are at this stage, what you can see is that now this pattern is complete. That means you are getting this pattern 3 to 2. That means you are going 3 to 2. Yes, this is correct. Now, one thing which we need to consider is that here 4 is previous and this part is next. So here you can see that this part is previous and this is next. So similarly, what we have done in with 2 and 3, we are going to do with 3, 2 and 4. We are going to consider this 3, 2 as a 1 unit and 4 as a 1 unit. And you can simply apply the same logic of reversal, that means same logic for reverse the links. That means you have to simply link one by one in order to make this 4 come previous to 3, 2. So after that, what you will get when you do that, you will simply get this one, and this is going to be our output which we have written. Now how we are going to do this, let's see. So as I have already mentioned that we are going to use three pointers. So let's see how we are going to do that. So firstly, in order to return the head, because here we are not going to return the tail as a head, we are going to take a dummy node. We can simply take a dummy node, and we are going to point that dummy node to our current head. And what will it will ensure that this dummy node is never going to change. And by this we are we are going to make sure that simply we are going to return the d next, that means dummy node next, as our output after the traversal, or you can see after reversal of this in between linked list. Now what we are going to do is that we have three pointers as previously mentioned: current, current next, and current previous and next. So first pointer which we have to make sure to connect at the correct position is going to be our previous one. So where we are going to where we should point this previous pointer is very important. Is that you can see that in order to reverse this links, you need to make sure that your previous pointer must be before the where the traversal starts. So here the traversal is starting at this position, that means 2. So we are going to point our previous pointer at the one pointer previous to it. That means this is going to be our previous. Now one thing to mention, that if you are given that you have to traverse it, or sorry, you have to reverse it from the first index, that means head, then our previous is going to be at our dummy node. Now this is clear. Now next what we are going to do is that you can see that in order to reverse this 2 and 3, what we have decided that we have to move or point this one pointer to this 3. So this is our thinking that we are to do. So in order to connect this, what will happen that this will break. So if this will break, then what you will lose is that you will lose this pointer, which is 2. You cannot access it because you have a pointer previous, but you do not have any pointer next to it. So in order to do not lose this node, what we can do is that before doing this linking, that means before linking this 1 with 3, we are going to take a next pointer, which is going to be our current pointer. So this is the current pointer, which is going to point at 2. Now we need one more pointer, which is going to be a temp pointer. We can take a simply a temp pointer, and you will understand why we are going to need this in the upcoming reversal, or you can say upcoming switches of these links. So firstly, what we have done, that we have break that link and we have linked to this position, which is going to be our 3. And after linking this to 3, we have break that, and we have already have access of this next pointer, which is going to be our 2, which has been pointed by two variables. First is current and second is temp vector, temp pointer. Now after this, what we have to do in order to reverse this, that we have to make sure that this 3 points to 2. So this is important, that this 3 next should not point to 4, it should point to 2. So here the similar situation arises, that if you break this, what will happen? That this will be going to be loose. So in order to make a continuous, or you can say we have to make sure that this node should not be loose, we are going to take another pointer, which is going to be our next pointer. So this is the next pointer, and we have break this link, and now we are linking this to 2. Now what we have done, we have linked our pointer 3, linked our node 3 to 2. Now after this, we have next one more pointer, which is 2 pointing to 3, and we have to make sure that this 2 point to 4. So let me draw what will going to be our outcome after this. So this is going to be our 3, this is going to be our 2, this is going to be our 4, and this is going to be our 5. So this is what we need. So after this, you can see that 1 is pointing to 3, 3 is pointing to 2. Now we have to make sure that 2 points to 4. So what you can simply do is that you can simply point our current pointer to the next pointer. So this next pointer will now 2 points to 4. So this is done. Now here you will see that this temp is not used, but this is going to be useful when you are at the next iteration. That means when you have to when we have to link this 4, and we have to when we have to reverse that 4 and this 2 3 part. That means this 2 3 and this 4, when we are trying to reverse this, then we are going to need this temp. Now let's see how we are going to need this. So after first traversal, what we get is that we get 1, next we have 3, next we have 2, next we have 4, next we have 5. So this is the position where we are now. Next what we are going to do, or what we need, is that we already have this our as a previous node. Next here you can see that we already have current pointer here. Now let's see. So again what we need is that we need to break this, and we have to move this to which position, to this 4. So this is important. So in order to, as we have previously done, so what we need to make sure that this will not be loose. So what we are going to do is that we are going to point is at 10. So this is important, that previously when we have declared it as a current, so we have to do it in before the loop start. That means it is initially be initialized as current, and this is initialized as previous. The temp part is going to be redirect reinitialized every time in the loop. So it is going to be previous next every time, and this is going to help us to make sure that this node do not be get lost. So what we have done, that we have break this link, and we have connected it to 4. Now after this, what we have to do is that we have to connect this fourth link, that means 4 next, to our 3. So what we need to do is that we need to break this. We have to make sure this is going to be our next, and after this what we are going to do is that we are going to point this to our 3. Let's point it. So this is going to be 1 to our 3. Now we have linked this. So after this what we need to do is that we need to link our current next. So previously we have current at this position. Here you can see that it is now at the next position, which is 2. So simply as we have done previously, that current next should point to next. Similarly when you do this, you will get that 2 will now point into 5. So this is the importance of temp here, that this is going to make sure that previous next is going to be known to us, and this current is going to be moved to this or traverse through this linked list in order to reverse it correctly. So I think you have already understand this by using this traversal. So after this two traversal, what you have got the complete answer. That means you got 1, then after you have 4, then you have 3, then you have 2, then you have 5. Now this must be clear to you. Now let's understand it by coding part also. So let's begin. So let's begin, and let's begin by taking a dummy node. This is going to be our dummy, and this is going to this is going to point to our head. So we are going to do that. So we are going to take list dummy node is equal to new list node, and here you can take any value. Let's take 1, or you can simply take 0. Now next what we need to do, we need to point this. We are going to write dummy. Next is going to be head. Now this is clear. Now after this, what we need to do is that we need to initialize a pointer which is going to our previous pointer, which we have discussed earlier. So we are going to initialize that pointer. It is going to be our prev is going to point to our dummy. So one thing which we have forgot is that how many times we have to run this loop. So we are going to take a note of that. So we are going to store that. It is going to be our, let's take L is equals to right minus left. So this is going to be the times of loop by which we are going to reverse this linked list. Now after this, what we are going to do is that we are going to run a while loop. And this while loop, we are doing this until our L is not equals to 1. Or okay. So until our L is, you can say left, until our left is not equals to 1. What that means, that we are going to point that our previous we are going to point this our previous node until the position where we have to begin that our reversal part. So before, from the starting point, we are going to point our previous node. So if the previous left is going to be 1, that means our previous is going to point to dummy, which is already been pointed. But if it is left is equal to 2, like in this first example, now it is going to point to our first head, that means 1. So what we have to do is that we have to move our previous pointer, previous equals to previous next. After this, we are going to simply do left minus minus. Now simply after that, what we have been doing, we are going to do it again. That means we have already understood that temp is going to change every time, but to think temp and next is going to change every time, but two pointer is never going to change every time. First is our previous pointer and second is going to be our next pointer. So we are declaring it previously. So we are going to take our current pointer, going to be current is equals to, so where it should point, so it should initially it should point to previous next at index which where we have to start our reversal. Now after this we are going to start a while loop, and this while loop we are running it until our L is not equals to 0. With part is L, so this is the number of times in which we are going to get our reversal. So in this what we are going to do is that we are going to do the same approach which we have discussed. First what we are going to do, we are going to initialize a temp pointer and it is going to be point to our previous next. So after doing this, what we are every time doing, we are going to point our previous next to which position. So this position where we are going to point is going to be our current next. It is important to note that we are every time pointing it to current next. So this time we are going to do it current current next. Now after this, what we have to do is that we have to again initialize our next pointer, which is going to be our next pointer. Now again, this is going to be list node next, and where it is going to point, so it is going to point to our position, which is going to be next to our previous one. So to get that position, what we are going to do is that we are going to write prev next next. So here you can see that how we are going to reach at this position. So previously we have this previous here, and after we have pointed this our previous next to this position, which is 3. So after doing our previous next, we are at 3, and again we after doing next, that means we are now pointing to this 3 next. So where we have to point this 3 next, so we have to point this 3 next to which value, which is going to be our temp. So this is what we are going to do in the next step. We are going to point this previous next to temp. So we are going to write previous next, which value is going to be 10. Now after completing this, the one thing which we are now left with is that we have to point this to our next pointer. So how we can access this to? So we can access this to by our current pointer. So this current pointer is moving through the loop, and it is going to be every time at the position which is last to the group of the nodes. If you are taking this group of nodes, so it is going to be at this position. So this is what we need. That means we need to point this point to the next which we have initialized. So we are going to write our current current next is going to be equals to next. So this is the complete code which is going to, what it is going to do is that it is going to reverse our linked list in the number of loops which we have discussed earlier. Now after this we simply do L minus minus, and we have to return our dummy node head, means dummy next. Now let's run this code. So this is accepted. Now let's submit this code. So this is successfully submitted. So this is the question for today, and here you can see that we have taken 0 millisecond. Now this is the question, and you will see the Python and Java code in the same video, so stay tuned. So this is an important question from the linked list part, and in the next video we are going to do the more interesting questions from the linked list. So stay tuned and keep looking to my YouTube channel. So thank you all.